In this video, we are talking about the kinetic molecular theory of matter, just like we've said previously. So we start by stating the kinetic theory of matter once again. Kinetic theory of matter states that matter is made up of tiny particles called molecules, which are in constant state of motion. So let's start with molecules. Let's look in depth at what molecules are. And we define molecules as the smallest particle of a substance which can have a separate existence and still retain the properties of that substance. Meaning that when we start grinding or piecing up a piece of any matter at all, or maybe let me say a piece of chalk, when you're rubbing it off, you're getting the very, very fine, tiny particles. So the molecule is the smallest division of that matter that we can find, this very, very smallest one that can have a separate existence and still retain all the properties of that substance. So some matter, or we can say some elements, are diatomic. What do we mean by diatomic? That's diatomic molecules. That's the smallest part of that element that can still retain all the properties of that matter must just be two atoms of that element. Some of them are monoatomic, meaning that one atom is enough to represent. So most metals, all our metals are monoatomic elements. They are monoatomic molecules. They can exist, one atom is like retains all the properties of that element. While most of our gases are diatomic, something like hydrogen. We write hydrogen as H2. So this 2 means that there are two atoms of hydrogen in this molecule of hydrogen. So if we have just one atom of hydrogen, like it can't exist on its own. It must be in a very, very like ionic state, or like hydrogen can't exist as one atom. It must exist as two. That is just one molecule of hydrogen. So having mentioned that some some elements are triatomic, diatomic. That is, tri means they exist as three, like ozone. Ozone is O3. So this is an ozone molecule. So we've been talking about atom. Let's look at this, the most simple structure of an atom. So an atom is the smallest indivisible particle that can take part in a chemical change. So let's just draw the structure of an atom. We have the nucleus, the centralized nucleus, and then we have electrons orbiting all around the nucleus. Something of this nature. This is the simplest structure of an atom. So the nucleus is at the center. The nucleus is at the center of the structure of an atom. So it is made up of protons and neutrons. And all these ones, the electrons, are orbiting around the nucleus. Electrons. So we have things that have charges. We have electrons have negative charge, protons have positive charge, and neutrons are neutrally charged, just like neutrons, neutral charge, protons, positive, then electrons, negative charge. The mass of an atom is mostly concentrated at its nucleus, at this center. The electrons are very, very light, and they are just outside, so they can always move out. And when an electron leaves an atom, that atom becomes an ion. So when it leaves, it becomes a positive ion. And when an electron comes from maybe another atom that is nearby and then enters the orbit of this atom, it becomes negatively charged. Why? Because this electron is negatively charged. So when let's even start by saying that every atom is neutrally charged. That is, in its natural state, an atom is neutrally charged. Why is it neutrally charged? Well, it has electrons, which is positive, negative charge, and protons, which is negative, positively charged. Now, the atom, a neutral atom, a naturally occurring atom that nothing has happened to it. The number of electrons is also equal to the number of protons. And you know when plus and minus come, they just cancel out each other, just like saying plus 1 minus 1 is equal to 0. You added 1 and then you subtracted that one again, it is equal to 0. And you know 0 is neutral charge, so no charge. So for each electron, there is a proton inside here to cancel out its charge. That's why an atom is neutrally charged. Now, how does an atom become charged? It is when electrons either leave that atom or the electrons enter into that atom. When an electron leaves, that means a negative charge has left. So this atom becomes more positive because the ones inside this neutron, this nucleus has really, really strong forces that are binding them together. They don't leave that easily, except when we talk about nuclear physics, whereby now very, very high energy is used to bombard the nucleus to loosen it up. But for simple chemical reactions, it is electrons that actually make chemical reactions to take place. Like electrons are the ones involved, like the members of the atom, like parts of the atom that makes a chemical reaction to actually occur, like involved in chemical reaction is the electrons. So the electrons, when they leave, this atom becomes positive because there is more positive charge inside than the electrons hovering around the nucleus. And then when an electron enters from a nearby atom into this our atom, this atom becomes negatively charged because one more negative, like one extra negative has entered. So all the positives inside here, when you now say plus, minus, there is one more minus here that the protons inside here can't account for. So that is why this atom becomes negatively charged when an electron enters it. And we've also said that the weight of an atom is mainly supplied by the nucleus. The electrons are really light, while protons and neutrons are kind of heavy. Like when we say heavy, it's not like they are really heavy. Atoms are really small things, but when compared to the weight of electrons, the protons and neutrons are way, way heavier than it. So the weight of an atom, the mass of an atom, is focused at the nucleus. So now, let's talk about the states of matter. Now, why are we talking about states of matter? Because we are talking about the particle nature of matter, and we are using the kinetic molecular theory to explain the particle nature of matter, in which it says that matter is made up of tiny particles called molecules, and the molecules are in constant state motion. So let's look at the states of matter and then observe how the molecules in matter of each kind of state behaves. So we talk about solid. The states of matter are solid, liquid, and gas. Now, at the end of this video, we are going to still talk about one more state of matter, but it's not really popular like that, and it is not just for your level. It is very, very high level physics, high level sciences that we talk about the fourth state of matter, or even sometimes the fifth state of matter. But for now, we just talk about solid, liquid, and gas. And we'll be talking about them under these headings. The volume, we'll be talking about the volume. We'll be talking about the volume, the shape. So these are the headings we'll be talking about, like we'll be using to explain these three states of matter. The distance between the molecules. Distance between, let's say molecule, let's say particles. Anyway, we said matter is made up of particles. So between the particles, or you can even use the word molecules there. Distance between the particles and the force of attraction between the particles. Force of attraction between particles and kinetic energy of particles. This explanation will really help us if we are told to compare between solid and liquid or liquid and gas. We will use these headings to do the comparison. So let's start with solid. Let's talk about the volume of a solid. A solid has a definite volume, a very, very definite volume. When we bring a box, okay, when we bring a cube of sugar, of sugar, we can see that the volume, like a cube, to get its volume, that is the length times width times the height. And all those things are equal for a cube because it's made up of 6 square faces. So it has a very, very definite volume. We can always measure it out. And if it's an irregular solid, we use the Archimedes method of measuring it out. And then for shape, a solid has a definite shape. This is a solid. This is its shape. This is always its shape. If we bring up another solid, it has just that definite shape. The shape does not change just like that, unlike liquids and gases. And then distance between particles. We say that matter is made up of tiny particles that are in constant state of motion. So when we talk about those particles, now a solid, we say that it is tightly packed. The molecules of a solid are tightly packed. So as they are tightly packed, we have like little or no space, like the tiniest of spaces when we are comparing between solid, liquid, and gas. We have the very tiniest of spaces between them. When we talk about the force of attraction between the particles, force of attraction. Now, what is making this solid hold together? Why is it not disintegrating as we left it this way? What is making it hold it together? We call it intermolecular forces. Let me write that down somewhere. Intermolecular forces. We call it intermolecule. So meaning that between the molecules of this solid, there is a force holding them together. So that's what we call intermolecular forces. So they are the force of attraction between the particles of a solid. So it is strongest. Remember that we are looking at this topic in comparing these 3 states of matter. So the intermolecular forces of a solid, they are the strongest. That is why solids are just rigid bodies. You can't change their shape that easily. Then kinetic energy of particles. Now, we said that temperature is the average measure of the kinetic energy of a body. Now, kinetic energy of the body is talking about the motion of those particles. We said that matter is made up of tiny particles which are in constant state of motion. So we are talking about what's the energy of these particles in a solid? What's their energy? How do they move? Because that's kinetic energy, motion. In solids, the kinetic energy is the least. The kinetic energy of the molecules of a solid. Like, since solids are tightly packed, the motion of its particles are not that much. It's just vibrating about a mean position. That is just at a position. Or the motion, like those tiny particles, we say that they are always in constant state of motion. They are just vibrating at their position. So let me say that my hands are the particles that make up a solid. My fingers are the particles that make up a solid. So the space between them is just very, very almost tightly packed, just little space between them. And then their motion is just little motion, little motion. They don't move. The particles don't move that much. That is why we can't even notice it, because at atomic levels or molecular levels, we need a very, very strong microscope to look at this at molecular level. So you can't notice their motion. Everything around us is in constant state of motion. We can't notice the motion of solids. Okay, so we've talked about solids. Now let's talk about liquids. Let's talk about their volume. A liquid has a definite volume. When we fill a cup of water with maybe 100 cl. Okay, or let's talk about a bottle of Coke, 50 cl. The bottle of Coca-Cola, 50 cl. it is 50 cl. Whether we pour it into a cup or we pour it into a bowl, it is still 50 cl when we measure it back in maybe a measuring cylinder or a burette or anything we want to measure it with. So it has a definite volume. Then shape. A liquid does not have a definite shape. It takes the shape of the container. So we pour it in a cup, it takes the shape of a cup. We pour it into a bottle, it takes the shape of a bottle. We pour it into maybe a toy, a transparent toy, you can see it takes the shape of whatever thing that thing is. So solids, liquids have no definite shape. Definite volume, no definite shape. Distance between the particles. Now we said that matter is made up of tiny particles. Now the distance between the particles, the molecules of a liquid, is more than that of a solid, but less than that of a gas. So let's say that we said that that of a solid is like this, then that of a liquid will just be like this. They will not give more space in between them. And then when we talk about the force of attraction between the molecules of a liquid will be less than that of the solid, but of course higher than that of a gas. Now, kinetic energy of particles, that's we're talking about the motion. They move more freely than that of the solid, meaning that the intermolecular, okay, we talked about the intermolecular forces, they are less than that of the solid, but higher than that of a gas. Okay, let's talk about gases. Gases has no definite volume, no definite shape. What do you mean by no definite volume? They fill up the volume of any container you want to have them in. And you can always compress them. You can always expand them. So they don't have a definite volume. For shape, of course, they take up the shape of any container in which you put them in. And distance between the particles is very, very far apart. Like their own is like this. And then their motion is just something like this. They move more freely. They move more erratically. So intermolecular forces is not that strong. That is why they can move more freely. That's the weakest intermolecular forces. The weakest force of attraction between the particles. And then the motion is the highest motion when compared to solid, liquids, and gas. Now, let's talk about plasma just as an introduction, because for this level, we are not doing anything with plasma as a state of matter. So plasma, we are told that it is the most abundant state of matter, but it is not around us, except when we have its application in plasma televisions, fluorescent lights, and the rest of them. Now, it is around the stars, the sun, and maybe the ionosphere of the earth. That is where we can find plasma as a state of matter. So in that state, the atoms, we have very, very high energy, very, very hot, and very, very high energy, that you now make the atoms to lose their electrons. And remember when an atom loses its electrons, it becomes an ion, right? Good. So now we have atoms existing as, like, we just have them. The electrons have been lost due to the high energy. They've gained energy, so they've left this atom. So they are now roaming around like negative charges. Then the atom itself, still carrying the protons, is now a positive ion. So that is the state, that is the plasma state of matter. So that is just all we need to know about plasma state right now. Let's talk about change of state. Change of state of matter, because we know that when we have something like water, we can have solid water, that is ice, liquid water, that's the one we can drink, and then gaseous water as steam. So change of state of matter. So when we have matter as solid and it gains heat energy, what does heat energy do? It gains heat energy, like the solid absorbs the heat energy. So it becomes kinetic energy, like the particles that make up that matter, the molecules of the matter, now they've gained energy, so they move more about. And part of that heat energy is also to break these intermolecular forces, the forces holding the molecules of this matter together. So it breaks it up, and then that matter begins, like the particles of the molecules begins to move more freely. And as this solid gains more energy, the energy now makes the particles to separate more, because it weakens the intermolecular forces until they become liquid. So that is what happens during change of state from solid to liquid state. And that process is what we call melting, right? So we have melting. And then when it melts, it becomes a liquid. Oh, I should have it rather this way. We have a solid, goes through melting to become liquid. And when we heat it the more, the heat energy reduces the intermolecular forces and as well as increases the motion of the molecules of the liquid until they get to gaseous state. So this is now a gas, and the process of change of state from liquid to gas is what we call vaporization. Okay, so we also have the backward change of state. We have steam, it condenses. So when we have gaseous state, condensation makes it turn back to a liquid. And then as we cool it more, and what happens during cooling? The kinetic energy, that's the heat energy, the temperature is being reduced because the heat energy is being taken away from that matter. Now as it's being taken away, the molecules don't move that much, and then that heat energy is no longer there to weaken the intermolecular forces, so they become stronger again. And then the motion of the particles, that is the molecules of that gaseous matter, that is the gas, now reduces until it goes back to the state whereby that matter can become liquid again. Very, very understandable. So as liquid, further cooling, that is further taking away the kinetic energy, that is what we call solidification, right? Solidification. We can even call it freezing. This one, melting or fusion. Evaporation is also here. So that's just about the states of matter.